the motivation behind cross product is applies only to a three-dimension, to R3. In other words, we don't have cross product in X and Y. We have only in X, Y, Z or higher spaces. And imagine that you have two vectors and you want to find a third vector that is perpendicular to both. Because this is, you'll see later on the theorem, the cross product theorem, that tells that the cross product theorem, that a third vector is perpendicular to two vectors. Let's say you have vectors A and B, and you want to find vector C that is perpendicular to both. That vector C is generated by the cross product of A and B. Okay. So what we do, we take, let's say, vector A, which is A1, A2, A3, vector B, B1, B2, B3, and vector C, C1, C2, C3. In order to have a vector C that is perpendicular to A, you do dot product. You do A dot C. Then think about it. What is A dot C? It's A1, C1 plus A2, C2 plus A3, C3. Now, if they're perpendicular to each other, then this result is 0. So you have one equation, right? Same with the vector B and vector C. If C is perpendicular to B, then B dot C equals 0. B1 C plus B1 C1 plus B2 C2 plus B3 C3 equals 0. You have second equation. You do a little bit of algebra, and you start solving for C1, C2, C3. Okay. And here's the result. So the result is the cross product. Okay, so let's write the cross product A cross B produces a third vector C that is orthogonal I mean, remind you, orthogonal perpendicular to, orthogonal to both A and B, such that A dot C equals 0 and B dot C equals 0. Okay? So the result, so if we let, I'm going to show you this. So we have these three vectors. So the first results give you A1 C1 plus A2 C2 plus A3 C3 equals 0, and B dot C give you something like this: B1 C1, B2 C2, B3 C3 equals 0. What we're going to do, remember how when you learned in college algebra or before that, you learn how to solve system by elimination? You want to subtract one equation from the other and eliminate. Unfortunately, we don't have any common terms here, but we can create one. If I multiply the first equation by, take this equation and multiply it by B3, right? Take this equation and multiply it. What am I missing here? A3. and subtract one from each other, then what do we have? So we have A1 B B3 C1 plus A2 B3 C2 plus A3 B3 C3 equals 0. And here we have A3 B1 C1 plus A3 B2 C2 plus A3 B3 C3 equals 0. And now you subtract. And here comes the elimination. How beautiful it is. Isn't it? What do we eliminate? We eliminate this B3 C3 and the A3 B3 C3, and at this point we have this expression. So we want to factor for C1 and for C2. So it will be A1 B3 minus A3 B1 C1 plus A2 B3 minus A3 B2 C2 equals 0. Okay?
Just by canceling out what exactly?
We have like terms, A3, B3, C3, A3, B3. Okay. I'm going to stop here because this takes more time. Continue solving. We obtain the following result. Okay, so you can continue by honing your own algebra skills. And this is what's going to happen. The solution is C1 are going to be the quantity in parentheses. C1 will be this quantity. A2 B3 minus A3 B2. C2 will be A3 B1 minus A1 B3. Notice the indices are changing the order, and C3 is A1 B2 minus A2 B1. This is the solution.
Wait, didn't we get rid of C3 and that's plus?
Yeah, but we need still to solve for it. So we need to do, we continue to do some algebra here, and we're going to express C1 in terms of, or C2 in terms of C1 until we solve it. Okay. So the vector C, so we end up having the following. We're going to say that this can be written, remember C1, C2, C3 are the component of vector C. So this can be written as the following. A cross B equal the vector C, which end up equal A2 B3 minus A3. Actually, let me write it a line below. A2 B3 minus A3 B2 in the, as if we write it as a vector, we'll write it like so, and then A3 B1, let me clean up here. I don't think I need the parentheses, so let me start over.
Oh, that was good.
There is no significant change. It's just I have a parenthesis, unneeded parenthesis. The first component, the I component, is A2B3 minus A3B2. Basically, it's the C1, C2, C3 that I wrote above. So there is no new knowledge here. Okay, so this is the result of the cross multiplication. It's easier to use determinant when you calculate a cross product. Okay, so we use determinant, a word that you may have forgotten since your day in pre-calculus, to calculate a cross product. Okay, if you have, so let's revise. What is the determinant? It's a scalar quantity, but we're gonna actually write it in a vector form. If we're looking at 2 by 2 determinant, and if you have something like this, you have a matrix that is A1, A2, and B1, B2. Okay, so each row is a vector. So vector A, vector B, and you want to find, you want to express the determinant. The determinant, since the determinant is scalar, we put it like so. Well, it's a quantity A1 times B2, in other words, one diagonal minus the other diagonal, which is A2, B1. Okay. What about 3 by 3 determinants? 3 by 3 determinants, we do it differently. I'll do it on the next page. When we work on the 3 by 3 determinant, let's say we have 3 vectors, A1, 2, 3, A, B1, 2, 3, and so on. So we'll write it like so. We can expand the determinant into 3 minor determinants. So how are we going to do it? We're going to expand it along the first row, A1, A2, A3. Okay, so we're going to write it like so. We'll take A1, and what we do, I need to use a couple of strips of papers here. We cover the row of or the first row, which we're always going to do, and then we cover the first column because we're going to do the determinant, the minor determinant that correspond to A1. Okay, so it will be the what you see is the minor determinant. So basically, we take a 3 by 3 or even higher, and we reduce it into until we have a 2 by 2. Okay, so the 2 by 2 corresponding to A1 will be B2, B3, C2, C3, and we know what's to calculate it. Okay, the next one that we're going to do is A2. So if you cover this one right there, okay, I can undo the split right now. So I'll cover this one, like so. So you have A2. Notice that I didn't put plus and minus here. I'll talk about it in a minute. And what I see is B1, B3, and C1, C3. Okay? And then I have A3, so I cover A3. And what I see is B1, B2, C1, C2, like so. So what about, what would be the sign in between? Well, there is something called Kronecker sign, German mathematician, but the sign that we apply to as we expand a matrix like the determinant, we start with positive and we start alternating positive, negative, like so. Because we can expand it along the B row or the C row. So, I'm sorry, this is negative, this is positive, and this is negative. So you alternate the sign. Okay, and back to positive, negative, and positive. So because we expanded along the A1, A2, A3, then we have positive, we have negative here, and we have positive here. Okay? And the way it works now, when you want to calculate it, then you have A1 multiply, here you have the diagonal, the major diagonal minus the minor diagonal, minus A2, B1, C3 minus B3, C1, and then plus A3 times, let me write it here, plus A3 times B1, C2, minus B2, C1. So this is how you evaluate the determinant of a matrix. But we are not solving for matrices. I intend to do something differently. But we're going to borrow this technique and apply it to cross product. Okay? We use the determinant. We need to calculate the determinant when we calculate the inverse of a 3x3 matrices or higher n by n matrices. Okay, we divide by the determinant. So, but that's a linear algebra course, so it's not in our course right now. But what we're going to do, how we're going to apply this knowledge to us. Okay, the way we do it, we're going to say that we let one vector A to be, say, A1, and here I'll go back to the IJK notation. So A1J, A1I, A2J, A plus A3K, and of course vector B will be likewise B1I plus B2J plus B3K. And if we want to find the cross product, we're going to say the following, that A cross B, we're going to set up something similar to a determinant, but in slightly different way. Instead of scalar, we're going to use the IJK as the direction. So this row will be vectors. So I'll mark it as a vector. Those are the standard unit vectors. And then here we're going to write A1, A2, A3, the component of vector A, and then B1, B2, B3 as the component of vector B. And now we're going to calculate the cross product using the same technique of expanding a determinant. So what it's equal to? It's equal to, we look at, remember, the first row is IJK. So if you look at IJK again, I'm expanding along the I. Okay, so what will be the minor determinant correspond to the I?
A2, A3.
It will be A2, B3 minus A3, B2. And those will be the component of the I in the I direction. like so. And likewise, so I can remove that. You can imagine what's going to be next. Remember, here we're going to stick a negative. So the negative in the minor will be A1, B3 minus A3, B1, but with the negative. And that will be the J component. And then for the K component, we go positive, and it would be simply A1, B2 minus A2, B1 in the K.